Hello, this is step 2 in our linear estimation. What I'm going to do is build a worksheet that's going to estimate or forecast via linear regression what future sales are going to be. So in order to do this, we're going to start with doing our years as a reference. So our data is from 1993 up through 2011. How do you do that? Go ahead and delete this. So we start with 1993, 1994, 1995, and at this point I'm going to go ahead and highlight my time frame. The little black box there, we're going to see a change in the cursor. Once the cursor changed, hold down the left mouse button and drag down. That's through 2011, 12, 13, and 14. And these other 3 years are going to be our forecast. In other words, we're going to forecast sales for 2012, 13, and 14. What we're also going to do is grab actual sales data for your stock, and mine, remember, is UTX, for 12, 13, if it's there for 14. And then we're going to compare our forecast from the actual and see how well each of our models did. We're going to come up with a number of different models. All right, in terms of getting our x's, same kind of thing. We start with, let me delete these guys. We'll start with 0, and then 1, 2, 3, 4. Highlight the group and go ahead and drag it down. Okay, so this is the x value, year 0, year 1, year 2, etc. This represents our y's. And what we want to do first is calculate the intercept. All right, we're doing a linear regression, so we're going to have an intercept and a slope. How do you calculate the intercept? We use the intercept function, so it's just going to be equals, and there we have our intercept. Our known y's, so the y values are what we call the dependent variable. That's going to be our sales data. And then a comma, and now we're going to highlight our known x's, which is just the years that we're interested in, up through year 18. We end that with a parenthesis and return. So our intercept is basically 14 billion. Slope, we're going to use the slope function, equal slope. Same thing, we're going to highlight our y's, do a comma, highlight our x's, end it with a parenthesis, and this becomes the slope. And that allows us to generate the forecast. Our forecast, go ahead and delete this. Our forecast is going to be equal to the intercept. And if you hit F4, you'll see these dollar signs show up. That means wherever I move this particular cell, it should always reference back to B29. And then we're going to add to that the slope of our line. And again, we hit F4, lock it into place, and then we multiply that by our x value. Okay? And we're good to go. So this is my projection or my forecast for the first year. Actual data was 21 billion. I forecast 14 billion, which may not sound very good, but we can go ahead and drag this guy down through each one of our years that we're interested in. And here we are in year 2011, which is 18 years of our model. I'm forecasting sales of 57 billion, actual sales were 58 billion. So while I had a lot of error at the beginning, by the time I got to the end, the error had actually come down a fair amount. And what is our forecast error? Well, that's pretty simple. It's always equal to the actual minus the forecast. So in this case, it was 65. And we can decrease the number of decimal points we have there since we're dealing with billions. Or I can right click, pick the cell, right click on it, and go to the format cell. Wait for my computer to catch up. And I want a number with, say, 2 decimal places or 0 decimal places. And then again, we can go ahead and drag this down. And I always have my format maintained from what my forecast error was. So in some places up here, I tend to under forecast significantly. Here, I'm tending to over forecast. I'm forecasting more than expected, and etc. And then you can also define this as the opposite, right? It's the forecast minus the actual. In fact, why don't we go ahead and do it that way? We're going to call it forecast value. This is what we expected, and we're going to subtract from that what our actual error data was. And drag that one down. Either way works fine. It's just a flip of the sign. We should use this second method more. Alright, so I have my forecasts, and I have my my forecast, my error function, how much my error, forecast error, and what the actual data was. Next thing we want to do is add a plot. And I have, as an example here, completed column in terms of, this is my linear forecast, what my data was, what the forecast was, and what the error ended up being, whether it was positive or negative. What I want to do is do a sales forecast associated with it. And then we're going to fit this particular line. And how do we do that? Well, what I want to do is come here to insert, and what we want to see is a line graph, and we're going to put points onto it. Alright. And then I'm going to come here to our select data, and we're going to add, and the series name is going to be sales, and the series values are going to be the actual sales data that I have. And we'll get in there, and then so we have at the bottom our dates, and then we have our relative sales data associated with it. So in this case it's going 1 through. What I want to do is come down here and modify or format the axis. Actually, what I want to do is come over here to our select data and change our horizontal column, and we're going to put the actual year in before I go to formatting the axis. So now we have our sales data, we have our year associated with it, and our minimum value is 21 billion, our maximum value is 57 billion. So I'm going to change this axis by formatting. So again, I'm clicking on the axis, I'm right clicking, then I'm going to format axis, and my minimum I'm going to set it at fixed at 20,000. Okay, our maximum I'm going to set it fixed at 60,000, and that's going to change the scaling of my graph to make it a little more appropriate. And then the other thing I want to do is come here and add a trend line. So again, to do that, I am clicking on the plot, okay, and then right clicking and saying add trend line. And we're going to do a linear trend line in this case. So this becomes the model, this is the line that's being fit. And we can also format the trend line. We can include like displaying the chart equation, and we can also ask it to display the R squared on the chart. So here's my chart equation. You'll notice this is the slope, and this represents the underlying intercept for it. Somebody's at the door. Hang on a second. Alright, I think I'm back. Sorry about the delay. So we have our slope and our intercept. Another plot that we want to add is how our error terms look. So we can highlight our error terms. Excuse me. We can highlight our error terms, and we're going to go ahead and insert a line graph again, showing our points. So this represents the error. Under our select data, we can edit the series and call this one the error. And then we can edit our axis label and add in our particular years. Okay, there we go. So this is our error plot in terms of years. What do you want this to look like? Well, you actually want it to randomly come above and below the 0 line. And what we see here is that there's a trend up, a trend down, a trend up, and then kind of randomize a little bit. What it's telling you is that the linear model that we have fit to this is not doing a very good job of forecasting. And if you kind of look at you want to look at your data, what you see is that from this point to this point, it's actually one line. There's one trend line that's going through this place. And then from here up to here, there's a second trend line that occurs. So here we have one type of growth for UTX. Here we have another type of growth for UTX. Then you'll see a big drop. And you notice that that's in 2007, 2008. So that's the recession. And then we start growing again, and we're kind of fitting the trend line at that point, or maybe assessing between the two. Now you got to apply a little bit of knowledge. One of the requirements of the project is for you to understand the stock that you're dealing with. Mine is UTX. One of the things that UTX does is supplies military equipment. So you'll notice here the trend line changed right around 2002, 2003. You have two wars going on for the United States, and suddenly the sales for UTX, United Technologies, goes up considerably. We hit the recession. At the same time, we're backing out of the military conflicts, and you'll see kind of a trend line change. Okay? So this is just the basic process that you'll go through in terms of assessing what your error structure is. Another function that we want to use is called linest. And linest is known as a matrix function. So I'm going to step through here. You got to know ahead of time. In this case, we're going to have two data points, or two components to our estimate. There's the intercept and the slope. So in order to do the linest, we need to start by highlighting a box. So there's two. And then we're going to come down here several boxes as well. And now we're going to use the linear estimation function. So I'm going to start by typing in equals and then linest parenthesis. Now we're going to pick our known y's. So our y's are our underlying data. And then we're going to do a comma and our known x's. We're going to select our x data and then a comma. The next two inputs are always going to be 1, 1. So it talks about the constant and the statistics that we're interested in. We're going to end that with a parenthesis. Now what you don't do here is just hit return. What we want to do is basically use this function and have it copy into all these boxes at one time. In order to do that, we need to hit Control Shift Enter. Hold down the Control key, hold down the Shift key, and now hit the Enter key. Alright, and that's going to populate all our boxes. You'll notice up here in the equation we have a brace on either side. That tells you that it's a matrix function. All right, and we have our slope, which is 2343, our intercept, which is 14,821. Below that represent the standard errors associated with it, and then our t-statistics and additional information. And I'll go through in class what all this is rather than here, or you can Google linest and find out what each one of the boxes actually represents. All right, just a little bit more to do on how to set up an estimate, or how to set up your forecast model. Next couple of things that we want to do is we want to find what the average of our error terms are, and it should be 0, and fortunately it is. Our next thing that we're interested in, and I'll go back to my, is the sum of squares, and we're just going to use this function known as sum square, and then our function for standard error, which you'll notice is the sum of squares divided by the number of observations minus 2. So we start at 0, we go to 18, there are 19 observations, we subtract 2 from that, and that becomes the standard error of the forecast. Okay? And we'll use this standard error forecast as we try and project off into the future. So just to actually type them in, so this is going to equal to sum SQ, and again we highlight our group, and now we want this one equal to the square root, SQRT, the sum of our standard errors divided by the quantity of 19 minus 2, which is the number of observations minus 2. Double parenthesis until you see the black, hit return, and this becomes our sum SQ, and this is our STD ERR. Alright, so that's the basic process. What you're going to go and do is estimate the linear model like we just did. We're going to look at a quadratic model where we're going to square the x variable. We're going to look at a quadratic model where we add the GDP in, and then we're going to do a log linear adjustment, in which case we're taking the log of sales values, and then we're using the log of that number to do the estimate as opposed to the actual sales data. All right, thank you very much, and look forward to class.